All right, so we're now in section 3 of chapter 5, and there's three topics of section 3. The good news is each one just deals with different formulas. Okay, so I won't, although it does kill me not to go through the proof of some of these formulas and where they come from, but let's just jump in and let me start with the first set of formulas. What we call double angle formulas. Let me go ahead and take a look. And so notice that there are some various double angle formulas. Sine of double theta only has one formula. Tan of double theta only has one formula. But notice that cosine of double theta, cosine actually has 3 different formulas to choose from. They all work. You would just choose the one that you think would be easiest in the problem. Okay, so no more talk. Let's get into it. So the first example. So what are we told? We're told that sine of theta is equal to 5/13. And we're told that theta, the angle, lies in the second quadrant. So theta is over here. What are we asked to do? We're asked to find the exact values, there's these words, exact values, of sine double theta, cosine double theta, tan double theta. All right, so as always, when you first start these problems, there's an initial amount of, how do I put it? Like initially, it's hard to start, right? We don't know where to begin. If sometimes just a little push and we're good, we got it. So here's something you can always try. If you're taking a test and you just don't know where to go, start by drawing. Let's draw that out. So remember, so let me come up here. So sine of theta, here's the information we're told, is equal to 5/13. And remember, sine is opposite, right, which is y, over the hypotenuse, which is r. So let's actually go ahead and figure out the x value of this point. So we know that, in other words, right now we know that y is equal to 5, and we know that r is equal to 13. What we don't know is x. That's what we're going to find out right now. But that's not bad. We can do that fairly easy. So we can just start with x squared plus y squared is equal to r squared. And I already know what to plug in, right? I know what to plug in for y, and I know what to plug in for r. So let's do that. So that means x squared plus 5 squared is equal to 13 squared. Okay, so let's finish this up. So x squared plus 5 squared is 25. 13 squared is 169. Subtract 25 from both sides, so I have x squared is equal to 144. Take the square root of both sides, and x is equal to plus or minus 12. Interesting. Wait a minute. Which is it? Is x, what is x? Is x 12 or is x negative 12? So that's why this little piece of information is needed. So tell me, if I choose a point here in quadrant 2, is the x value negative or positive? Right, so the x must be, in order to be a point in quadrant 2, the y is positive, but the x is negative. Agreed? So we now know to choose the negative 12 for this problem. So x is equal to negative 12. All right. Well, let's see what we can do with this information. So let's start with sine double theta. So remember from the formula, just, all I'm doing is grabbing this formula, and let's rewrite it. So sine of double theta can be rewritten as 2 sine of theta multiplied by cosine of theta. All right. So let's see if you can follow me. So this is going to be 2 times sine of theta. Do we know sine of theta? We do. We're told sine of theta, right? Sine of theta is 5/13. So I'm literally just going to drop 5/13 in here for sine. So that's 2 times 5/13. Now, what about cosine of theta? Well, don't let me lose you. Cosine of theta. Remember, if sine of theta is y/r, cosine of theta is x/r. All right, do I know r? I do. R is 13. Do I know x? I do. X is -12. So I can rewrite this as -12 over 13. And there's nothing left to do except, let our calculator do the heavy lifting and multiply all that out. The result is -120 over 169. That's the exact value. No decimals, right? Here we go. Cosine of double theta. Well, notice that we have 1, 2, 3 options to choose from for cosine double angles. Now, it doesn't matter to me which one you choose. I'm going to go ahead and go with the first one. So let's see if you can follow me here. I'll change the colors. So cosine of double theta can be rewritten as cosine squared theta minus sine squared theta. And the reason why I chose that is, do we know what sine is? Right? Well, yeah, sine is just 5/13. So all I have to do is drop 5/13 in here and square it. And do we know what cosine is? Yeah, cosine is -12/13. So all I have to do is drop -12/13 in here and square it. All right, let's go ahead and do that now. So that just comes out to be -12/13 squared minus what? Minus 5/13 squared. All right, and let's just finish it up. So we just square and then subtract. We end up, I'll go ahead and write it, 144 over 169 minus 25 over 169. And here it is. That is, all of that is equal to 119 over 169. There's the exact value. All right. So I'm going to go ahead and finish the last one, tan double theta, using our double angle formula for tan. But for those of you that are, if you're kind of bored is, it's not fun to be bored, but it is a good sign in mathematics because it just tells me that you are anticipating what I'm going to do next, and it's easy for you. So here's let me ask those of you that feel like this is easy. I'm going to go ahead and get us to our answer for tan of double theta. My question to you is, how could I have got there a lot faster using the 2 answers that I already have? All right, let's finish this up. So tan of double theta, we can go ahead and let's use our double angle formula. So that can be rewritten as 2 tan of theta divided by 1 minus tan squared of theta. All right, and let's take a second and give myself a little bit of space here. So sine of theta is y over r. Cosine of theta is x over r. What about tan of theta? Yeah, tan of theta is what? It's just y over x. All right, so let's rewrite this. So this is going to be 2 multiplied by, well, tan of theta is y over x, and we already know y is equal to 5 and x is equal to negative 12. So that's negative 5/12. So 2 times negative 5/12. All right, that's in the numerator, and let's see what goes in our denominator. So that 1 minus tan squared, so that's 1 minus, well, if tan is negative 5/12, then tan squared is just negative 5/12 squared. All right, at this stage, I mean, we just got to clean it up. I mean, we distribute, we combine, but in the end, after you have, I'm going to skip this because I don't have the spacing to do it, and these are skills that you would have or should have mastered by now. But what we end up with is negative 120 over 119. So here is the final answer. All right. So how could I have gotten there? How could I have gotten there a whole lot faster? See if you can spot the pattern. But nevertheless, we have used the double angle formulas. All right. So now remember back in, this is 5.3, but remember back in 5.1, you were verifying identities. And one of the things that you need to be aware of is sometimes you have to use these double angles or sum and difference formulas in the verification process. So see if you can follow me here. So I have cosine triple theta, and I'm supposed to make that, I'm going to pick the left side, and I want to make that look like the right side. I want to make it look like the right side. So let's see how we could do that. Well, foremost, cosine of triple theta, do you agree with me? It's just cosine of 2 theta. My apologies. It's just cosine of 2 theta times cosine of theta. And now, my sincere apologies. I wrote that incorrectly here. I think I'm starting to get tired. What I meant to say, cosine of triple theta, it can be thought of as cosine of 2 theta plus theta. That looked weird for a second, but now I know what I was doing wrong. So of course, if you have 2 thetas, you add another one, we have 3 theta. So we could think of it as the sum of 2 angles. But is there a formula out there that we could use that would help here? So let's see if we can get through the rest of this. So we're going to have to use a sum. We might have to use a sum and difference formula. We might have to use a double angle formula. But nevertheless, let's see what we can do here. All right, so if we look up, I'll go ahead and write it. If we were to go back to our previous section and look up our double angle, and our sum and difference formulas, we would see that cosine of alpha plus beta, the formula that we use for that is cosine of alpha times cosine of beta minus sine of alpha times sine of beta. So this is right from section 5.2. But now my question is, what are we going to use for alpha, and what are we going to use for beta? Well, do you agree with me that alpha in this case would be 2 theta, and beta in this case would just be theta? All right, so what we're going to do right now is we're going to substitute alpha and beta in to the sum and difference formula. Let's go ahead and do that right now. So wherever there's an alpha, we're going to put 2 theta. Wherever we see a beta, we're just going to substitute a theta. Let me go ahead and do that right now. So that's going to be cosine of, I'll go ahead and leave them blank for just a second, just so you can see exactly where I'm plugging them in from. All right, so let's make sure you understand. So alpha, in this case, is 2 theta. So we're going to plug a 2 theta here. And then beta, cosine of beta, is just theta. We're going to plug that in right here. Same thing over here. So it's going to be 2 theta and then theta. All right. So remember, if I've lost you, we're trying to make the left side look like the right side. Can we do it? I picked a hard problem, by the way. Okay, so first let's agree. So right now, what we have does not look like what we need it to look like. But hold on for a second. We do have ways of rewriting these double angles, don't we? Right? That's what we've been working on. So we're gonna use the following double angle formulas. So we're going to use the double angle formula for sine. And since we have some choices of what to use for cosine, we're going to do that. Let me just show you what's about to happen. So let's see if you agree with me here. So what I'm boxing in the yellow brackets, that's going to be our double angle formulas. Ready? Let's go ahead and go. So let's start with sine. Well, the good news, sine double theta. There's only one formula for sine double theta. Let's go ahead and plug that in. So that's 2 sine of theta times cosine of theta. And now we have to choose what formula to use for cosine double theta. I'm going to go ahead and use 2 cosine squared theta minus 1. All right, we're actually pretty close. Just, does it make sense that in order to verify, in order to make the left side look like the right side, we first had to use our sum and difference formulas. We also had to use our double angle formulas. Now that we're here, all we have to do is clean it up. So let's go ahead and distribute cosine of theta times, we're going to go and distribute here. We're going to distribute here. So let's go ahead and do that. So what would that look like? So we have 2 cosine squared times cosine of theta. That's going to be cosine squared times cosine is going to be cosine cubed. And then, so we distribute here. So now let's cosine times -1. So that's minus cosine of theta. All right, and let's see what else we got. Minus Well, this is pretty easy. If you sine times sine is sine squared. So this ends up being minus 2 sine squared theta cosine theta. All right. So it still doesn't look like the right side of the equation, but what else can we do? Well, let me, this is a long problem, so let me get you to it. We got one more step here. Do you remember that sine squared theta, that's just one of those Pythagorean identities? I can write that. Let me write everything else. To entertain yourself for just a second. So I can rewrite sine squared. That's the only thing that's going to change. Sine squared can be rewritten as 1 minus cosine squared. All right, I know you're struggling. So listen, we're done. We got to distribute here, and we got to combine like terms, and everything's done. Ready? So let's go ahead and finish it. So if I distribute my negative 2, I would have, just make sure you understand, you have to distribute your 2, and you're distributing here as well, right? So I'll just write it. I don't think you'll have trouble following me. But if you do, you just let me know. So that's going to be minus 2 cosine of theta. And then I got to distribute one more time. That's a negative and a negative, so that's plus 2, and now that's cosine cubed theta. All right. So I have 2 cosine cubes here. I have 2 cosine cubes here. So if I combine them, I actually have 4 of them. So 4 cosine cubed theta. And I have a negative 1 cosine of theta here and a negative 2. So negative 1 minus 2 is negative 3. And we're done. That's a tough problem. That's about as tough as I can make it in due honesty. Hopefully you were able to follow me through that problem. Okay. So actually, we'll go ahead and that was 2 long problems. I'll go ahead and make this a 2-part section, and I'll see you when I get back.